Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is DonnyFarhan. I am from Telecommunication B class, third grade. Today I'm gonna show you my presentation about my purpose for my final project. Okay, the title for my final project is Implementation of Selective Mapping or SLM method, SPAPR reduction and linearization technique in OFDM system using Universal Software Radio Peripheral or USRP with LabVIEW and Python. The first roadmap from this presentation is background. Number two is research purpose. Number three is formulation of the problem. Number four is problem limitation. Number five, diagram system. And then number six, the last is expected result. The background of my final project is OFDM or orthogonal frequency division multiplexing system is a multi-carrier modulation technique used in today's and future wireless broadband communication systems for high data rate transmission. But OFDM also has a disadvantage, the high value of PAPR or peak average power ratio. Many methods have been proposed to reduce the value of PAPR, one of which is using SLM technique, which is the technique I will use for my final project. The purpose of my research is to implementing the selective mapping or SLM method to reduce a high peak to average power ratio or PAPR in OFDM system. So the SLM should be reduce the PAPR value in OFDM system. Formulation of the problem. First is how to use Python program to implementing selective mapping method to reduce PAPR value in OFDM system, and then how to set an OFDM system in LabVIEW. So the Python will be implementing the SLM, and then the LabVIEW will be create an OFDM system and then connect it to the USRP. And Python program will be linked to the LabVIEW. Problem limitation. First is modulation used, uses USRP 2920, and then subcarriers used. And this is the diagram system. There will be two pieces as a transmitter and as a receiver. And the method, SLM method, will be on the transmitter side. And this is the diagram system of OFDM. First, bit stream goes to modulator. Modulator could be maybe KAM or KPSK or PSK, but maybe I will use the KAM for my final project or my research. And then from that, it goes to serial to parallel converter, and then goes to EFFT. EFFT is converting the signal from frequency domain to time domain. And then from that, it goes to parallel to serial to make it a serial signal gain. And then it's go to add cyclic prefix. Cyclic prefix basically work as a guard band to prevent the interference. And then from that, it goes to DAC or digital to analog, and then send to antenna, and then send to the receiver. From the receiver is the reverse version of the transmitter. First, it's convert to the analog, and then remove the cyclic prefix because we don't need again the card, and then make it parallel, and then make it to frequency domain again, and then make it a serial, demodulate, and then the signal will be received. This is the diagram system of selective mapping. First, input data goes to serial to parallel, and then divide to some subblock, and then multiply it with P. P is phase unit, and then from there it goes to EFFT, and then from EFFT, this is will be choose the low value from the multiplied. Linearization is to make a nonlinear power to linear by adding a predistortion before the high power amplifier. And then the expected result on this project is reduce PAPR value in WebDAM system using USRP with LabVIEW and Python. And that's all. That's from me. Thank you for watching.